Hi, welcome back. We are still on Unit 11, Day 2. In the last video, we looked at compound probability and we determined if events were independent or dependent. And when you have more than one event, we talked about that you are multiplying the probability of each event occurring to each other. So we multiply the two probabilities, reduce the fraction if necessary, and we can also look at it as a percentage. Okay? All right, when you're repeating an event, if you're doing the same event twice, it's important to consider whether it's done with replacement or without replacement. Okay, so when I look at this bag of marbles here, it says it should say bag, and that says bag. A bag contains 4 black, 5 green, 6 red, and 7 blue marbles, and we're going to find each probability. Notice it says with replacement, and it says without replacement, and that is really important. When you're doing something with replacement, that means in between each pulling of a marble, you're going to put the first marble back, okay? Without replacement means that you are going to take out the first marble and you're going to hold on to it and then pick out the next marble, okay? So the first one says, what's the probability of pulling a black marble and then a blue marble? So the probability of pulling a black marble and then a blue marble. Okay, to pull a black marble, my probability is going to be, there are, 4 black marbles out of, there are 4 black marbles plus 5 green marbles plus 6 red marbles plus 7 blue marbles. 4, 5, 6, 7. 4, 5, 6, 7. There are 22 total marbles. Okay. Then I want to look at blue marbles. There are 7 blue marbles. Now it says with replacement. So that means there are still 22 marbles in the bag. And we're going to multiply these together. I'm going to we'll go with pink. There's no pink marbles. All right, so 4 times 7, 22 times 22 is 484. That is going to be 28 divided by 484. Math, fraction, enter. 7 out of 121. Which is, math, turn that into a decimal, multiply it by 100, and that is I'm just going to round to the tenths place for space's sake, 5.8%. Okay, now let's look at without replacement. So without replacement, my probability of getting a black marble the first time I pull a marble out when I'm starting fresh is going to be still 4 out of 22. Okay, but now when I go to pull my blue marble out, okay, there are 7 blue marbles in the bag, but I'm holding on. I've pulled out a black marble already. So I've already pulled out 1 marble, which means now there's only 21 marbles in the bag. So that is going to affect my probability when I multiply these two together. So when I multiply them together, I'm going to get still 4 times 7 is still 28. But now I'm going to do 22 times 21, which is only 462. So now 28 divided by 462, math, fraction, enter, 2/33. Which until I make it into a decimal, it's kind of hard to see how much my percentage has changed. So let's see. I'm going to say math. Let's look at that as a decimal now. Multiply it by 100. And it is now 6.1, if I round to the tenths place, %. So it's more likely that if I pull a black marble on the first one, that I'll pull a black marble on the second one if I keep the black marble in my hand, because it makes less black marbles to choose from still in there, but you still have the same amount of blue marbles to choose. Okay, so my percentage increases. All right, let's look at the probability of drawing a red marble and then a green marble. So we want a red marble first. There are 6, and we're starting fresh with each problem. Okay, each time we start with a fresh bag of marbles. So 6 red marbles out of, I know there's 22 marbles when we start in the bag. Then I want green. There are 5 green marbles out of, now with replacement means I pull that red marble out, I go, oh, okay, it's red, and then I put it back in the bag. I replace it in the bag. So there are still 22 marbles to choose from when I'm trying to pull this green marble. I'm going to multiply these together and see what we get. So when I do that, let's do purple this time. We are going to get 6 times 5. 22 times 22, we already did that. That's 484. That reduces to 30 divided by 484 is, oops, I wanted that as a fraction. Math, give it to me as a fraction. 15 out of 242. And as a decimal, we'll go back to decimal, times 100, we're going to get 6.2%. 6.2% of the time, I should pull a red and a green marble, one after the other, putting the marbles back each time. Okay? All right, now let's talk about without replacement. So my first probability is not going to change. I'm starting with a fresh bag. But then I'm going to take that red marble out and go, oh, that marble is red. I'm going to keep it. And now I'm going to try to draw a green marble. So my green marbles, there's 5 green marbles in the bag, but I'm holding on to a red marble out of these 22. So now there's only 21 marbles in the bag. So when I multiply these together, I do still get 30 on the top, but now I'm multiplying 22 times 21, which we know is 462. So as a reduced fraction, 30 divided by 462, math, fraction, enter, 5/77, which as a percentage, math, make it a decimal, enter, times 100 is 6.5%. So I have a little bit better chance there. Oops. I want to put my box around both the fraction and the percentage because they are both correct answers. Okay, and last but not least, I want to draw a blue marble and then another blue marble. Okay, so with replacement, a blue marble, there are 7 blue marbles out of 22 marbles. Then I look at it and I go, oh, okay, it's blue. I put it back in the bag. So there are still 7 blue marbles out of 22 total marbles. So I know on the top, I'm going to have 49. And on the bottom, I'm going to have 484. 49 divided by 484, math, give it to me as a simplified fraction. It's still 49 out of 484. That doesn't reduce. Okay, so as a decimal, math, give it to me as a decimal, times 100. Okay, and this is our most likely case so far, 10% of the time, 10.1% of the time. I'm going to pull 2 blue marbles, which makes sense. There's more blue marbles in the bag than there are any other color, right? That's my biggest number of colored marble. Now, without replacement, notice each time 5.8%, 6.1%, it went up, 6.2 went up to 6.5. So we can kind of use inductive reasoning and assume it will go up. Let's see. So we're going to start with 7 out of 22 because we're starting with a fresh bag. And I'm going to pull out that blue marble and go, ooh, it's a blue marble. I like it. I'm going to keep it. This time I'm not going to put it back. I'm going to keep it. So now there's only 6 blue marbles in the bag because I'm holding on to a blue marble. And there's only 21 marbles in the bag because I'm holding on to a blue marble. Okay, so 7 times 6, that's 42. 22 times 21 is 462. 42 divided by 462. Math, give it to me as a fraction. 1 out of 11. 1 out of 11, math, give it to me as a decimal, times 100 is 9.1%. So we actually went down by a full percentage point when we're pulling out the same color and not putting the first one back. So that's kind of an interesting, it goes kind of counterintuitive to the inductive reasoning when we looked at the pattern. But part of that is because we were pulling out a marble, so we didn't just affect the denominator. We pulled out a marble without replacement that affected also the numbers in the numerator. So that's what made this go down instead of going up like it did in the previous 2 cases, because we pulled out something that we wanted to get the second time. Whereas in the first 2 cases, the marble we were pulling out was not the marble we wanted the second time, so it actually increased the chances for getting that marble the second time. Okay? All right, hopefully your understanding of with replacement and without replacement is a good one. If not, make sure you're asking your teacher during Zoom or after Zoom if you're in person, or if you're not, during your tutoring time. All right, thank you so much for watching.